Hi, Alison. So I'm just going to do a quick video on to try and answer your questions here that you had about some of the calculus related rates type work that we're doing. Okay, so as the Blackboard opens up, the first thing you ask me is when you're solving something like dv/dt or dr/dt, uh, uh, and you take the derivative, why do you leave the number in front as it is? For example, when you were solving dv/dt for a cone, why do you leave pi over 3? Okay, so that is a good question. Why do I do that? And the reason I'm doing that is simply because we are using the power rule. So if we had a cone here, so let's say, well, let's just do let me get this out of the way there. Get out of the way. There we go. And let's make this a little narrow. Okay, so if we had the volume equation for a cone is pi over 3 times r squared h. Okay, the reason that, Elson, that we are leaving this in front is this is just a number. So if you think of pi as 3.14 over 3, it's basically 1 point something in front of this. So when we're taking a derivative like 3x squared, we leave the 3 in front. We go 3 times 2x equals 6x. And we're going to do the same thing. Now, the other reason that we're using the dr/dt and the dt and all that kind of stuff is for if we have an expression like this, you'll notice that we have two variables or three variables, one for volume, one for radius, and one for height. There is no variable for time in here. This is why we have to put dr/dt in. dr/dt stands for derivative with respect to time. So if they give us a dv/dt, let's say 40 cubic centimeters per minute, if they give us a dv/dt, we can relate it in the equation if we take the derivative of it and set it to 0, or set it, in this case, to 40.40, we can relate it at a particular point in time. So if we said this cone was let's say it was 12 centimeters high with a radius of 3, we could do it, okay? And the reason we can't, we have to replace one of the variables in it is because you can't do a derivative of two variables in the question, or more than two variables in the question, and have it work out nicely. So what we do in grade 12 is we convert one of these variables into the other based on the diagram. So let's say we wanted the derivative with respect to r. We wanted to find dr/dt, which means we want to find how fast the radius is changing, per minute. Okay, so we have to eliminate the h. That means we have to solve h into an r, and we can do that by this ratio. R over h in the cone is 3 over 12. So if you cross multiply and say 12 r's equals 3 h's, okay, and we want to eliminate the h, so we want h in terms of r, so we've got to divide both sides by 3. So h is going to be 4 r's. So that means we can plug that into here. So we have pi over 3 r squared times 4r. Okay, and now it's just v with respect to r. Now, since we have dv/dt is 40 centimeters a minute, cubic centimeters a minute, we can now find the relationship for dr/dt. So they might say when the radius, or when, what is that when the radius is, how fast is it rising? when the radius is a certain amount. Okay, how much around here it is. Let's say when the radius is 1. So they want to know it at a certain point when the radius equals 1 centimeter. Okay, so why you do dV/dt? So dV/dt represents how fast the volume is changing, but with respect to time. So now we can use the derivative of this. So first thing we got to do is combine them. So this would be V equals 4 times that is 4/3 pi r cubed in this case. Okay, and then we just take the derivative of that. So dV/dt equals 4/3 pi, because that's a number. Okay, now we take the derivative of r cubed would be 3r squared. Then we have to multiply it by dr dt because we're trying to find it with respect to time, and this doesn't have it there. So this is called implicit differentiation. And then this would be the equation that we'd use. We'd put the 40 in there, we'd put the 1 centimeter in there, and then we'd be able to solve for this. Okay. Hopefully that answers your question, Elson. I'm going to throw this back to you here this morning. And if it doesn't answer your question, email me back, and I'll try to describe it or just explain it in a new or better way for you. Okay? So good luck with that. Let me see. I got to get my preview here so I can turn off the video. Okay, so hopefully that'll help you. Let me know if it doesn't. Okay, and if it does, or if it does, and good luck.